So in this section, we're going to use our truth tables to determine whether a series of statements called arguments are either valid or invalid. So I'm going to begin with an example. Our problem says, if the sky is blue, then the sun is shining. The sky is blue. Therefore, the sun is shining. The first step in this process is to take our three sentences and translate them into symbols. In order to do that, we need to identify which sentence is the first premise, which sentence is the second premise, and which sentence is the conclusion. Now, a premise is a statement that provides evidence for the conclusion. So the easiest place to start is by identifying the conclusion statement, and then we can work backwards. So the conclusion is going to be easy to find because of the word therefore. Therefore implies that the conclusion is to follow. So if the sky is blue, then the sun is shining. The sky is blue, therefore we're about to make the conclusion. Therefore, the sun is shining. So I'm going to type that here. And we've identified the conclusion. Now, the other two sentences will therefore sort of by default be premise number 1 and premise number 2. So I'm going to make the first sentence, and it doesn't really matter which is which, but I'm going to make the first sentence premise number 1. So it tells me if the sky is blue, then the sun is shining. And premise number 2 says the sky is blue. So that's the first thing that you need to do is take the three sentences, identify which one is premise number 1, which one is premise number 2, and most importantly, which one is the conclusion. Okay, once that's done, then we need to translate those sentences into symbols. So in order to do that, I'm going to go back and identify a P and a Q. Now, I'm going to start by looking at premise number 1. And I note that premise number 1 is a conditional statement. It's the if-then statement. Right? And I know that the if-then statement has an arrow as its symbol. I know that the P normally is in front of the arrow and the Q is behind it. So using that, what I'm going to do is come back over here and I'm going to say, okay, the P will be in front of my connective, which is the word then. So the sky is blue is going to be the P. And then after the connective, we'll have the Q. So Q is going to be the sun is shining. So in other words, we're going to use that first premise to help us define what the P and the Q are. Okay, and we have it now in symbols because we have, over here, we have P, which is if the sky is blue, then, which is the connective, and Q, the sun is shining. All right, let's look at premise number 2. Premise number 2 says the sky is blue. So that is only a P. Remember, P is the sky is blue, and so if that is premise number 2, then we'll just have a P. And then the conclusion says the sun is shining, which is the Q. We identified Q to be the sun is shining. All right, so now we've translated it into symbols. Now we're going to put it together into a statement that we can use on a truth table. So the way that we're going to do this in every example is we're going to do, and I'm going to kind of jot it up here so that we have it, we're going to do premise number 1, and premise number 2. So we're going to put those together with an and symbol in between. We're then going to use this symbol, which is not one of our connectives. That symbol simply means implies, and it's going to imply the conclusion. So for us, premise number 1, we said was P arrow Q. Then remember, you're going to put the and symbol in between your two premises. So we're going to put and I would probably need this in a set of parentheses just to keep things clear. And then we'll put premise number 2. Premise number 2 is the P. We'll put our symbol for implies, and it implies the conclusion, and so it implies Q. And so when we do our truth table, in the next step, we're going to do a truth table for this compound statement. All right, so let's go ahead and look at what that's going to look like. So we've now got it in symbols. We know what we need to construct the truth table for. Okay, I'm going to rewrite my compound statement up here so that we know what it is that we're trying to work on. All right, so we had P, then Q. We had the and symbol. We had the P, and we had the implied arrow equaling the Q. All right, so let's make our truth table for this. All right, so we know that if we have a compound statement with only P's and Q's, that the first column is going to be P, the second column is going to be Q, and it's going to be fixed. So the P column is 2 trues and 2 false values. The Q column is true, false, true, false. All right, so now we start working on building the left-hand part of the connective statement. So I'm going to start right here, and I'm going to build P implies Q. All right, so let's copy first. Underneath the P, I'm going to copy the P values. So T, T, F, F. I'm going to put my arrow in. Okay, so that arrow went in, and then I'm going to copy the Q values. So the Q values are here, TF, TF. All right, and now we need answers for those 4. So I know that on my if-then table, the only way that this is false is this case right here. The other 3 cases are true. All right, so that takes care of the P arrow Q. So this part is done. Also on the left side, we have a P. We have that P column sitting right there, so that part is done. So then I would need to put those 2 together with the and in between. So that'll be my next step. P arrow Q, and we'll put the and symbol and then the P. All right, so again, let's do a little copying. So I'm going to start by copying the answers that I got when I did P arrow Q. So that's going to be copying these answers. So true, false, true, true. I'm going to put my and symbol in. Then I need to copy the P answers. So those are over here. So true, true, false, false. And now we need answers for these 4. These are our and statements. So you want to think about when your and statements are true. So I know that my and statements are true if they're both true. But in any other case, an and statement is false. All right, so now we have completed the left side. We'll now go ahead and write the entire problem down in this last spot. So I have P arrow Q and P, and then I have this double arrow symbol, which means implies, and the Q. All right, so again, we're going to start by copying. So this entire part right here is going to be copied from over here, the answers that we got when we did that part. So T, F, F, F. Now, this implied symbol, when we're putting it into our truth table, it goes in as just our regular arrow. So it becomes like an if-then statement. All right, and then we're going to copy our Q's. So we'll copy from over here, TF, TF. All right, and then we'll use our if-then chart to come up with our final answers. So we know on the if-then chart that the only one that is false is true, arrow F, which we don't have that one. So all of these are true. And so our final answers are true in every case, which remember we call this a tautology if it's true in every case. Now, the last step in this process is to determine whether your argument was valid or invalid. So in other words, going back to our argument, if the sky is blue, then the sun is shining. The sky is blue, therefore the sun is shining. We want to know if that's a valid argument or not. So valid arguments are those that are tautologies, that are always true in every case. An invalid argument is false in at least one case. And since we identified our problem as a tautology, we know that we have a valid argument. And so I would want to come back to my problem and make that note that what we have worked out is a valid argument.